next speaker is Ali, and he's going to take a deep dive with what lies under. So go under the hood. Welcome, Ali, please.
Hello, good morning. Can you guys hear me? Loud and clear? Yeah, good for you. So, good morning, everyone. My name is Ali, and I've been writing Golang code for about 5 years. But today, it's not about me, it's about you. Imagine going to attend a conference where you get to talk to creators of Golang, and not only talk to them, express your concerns and problems you have been facing about this language, get answers from experts, and in this process, learn Golang's philosophy better and learn how language designers actually think. So the stage is set, the founders are here, and you get to attend this conference. Now, the founders are on stage, and in the audience, there are 6 angry people waiting to ask their questions. Now, the first one stands up and says, my application freezes out of nowhere. So what they're experiencing is their application randomly freezes, and they don't know why. Well, the root cause for this is how the garbage collector works in Golang. So let's try and understand how it works. So it starts with whenever your application heap doubles, or every 2 minutes forcefully, your garbage collector will run. Now, the first step is pause everything. So when your garbage collector runs, it practically pauses your whole application. And once your application comes to a complete stop, the next is the mark phase. So what it does is checks all the active objects and marks them as active. Now, once you know which all your active objects are, what's the next phase? Well, it erases all the active objects and sweeps them out of the memory so it can be allocated again. Once all the garbage collection cycle is done, what is the next phase? Your application resumes. Now, what could go wrong with this approach, right? Well, it's in the name, stop the world garbage collector. Well, what it does is it completely stops your application. Imagine trying to sell 1,000 stocks, and as soon as you click on sell, your application stops. Well, the only thing getting garbage collected is your money. Well, along with some free objects, but anyways, who cares about them at this point, right? So how do you fix it? Well, the next phase of garbage collector improves it significantly. How? Let's take a look. Now, this is a tricolor algorithm, and well, basically tricolor means 3 colors, right? White, gray, and black. So white means the objects which are free and can be reallocated. Gray means these objects are active and need to be scanned. Black means active. So let's take a look of how this algorithm starts, starting from stop the world root graying. So you pause your application for a very small time, and you mark all your active root objects as gray. Once this step is done, your application resumes. Now the garbage collector will work concurrently with your application. Now, what the algorithm does is it picks up every gray element and checks what this object points to. So this gray element is painted black, and any element it points to is painted gray. Once this step is done, now there is a last phase in the mark step. So we pause the application for a very small time again to ensure correctness and ensure that no gray elements are left. Once that is done, we resume the program again, and the next sweeping step is done concurrently. So now this improves garbage collector significantly, and the pauses in the previous garbage collector was about 10 to 50 milliseconds, And this improvement has made it significantly better. And the pauses, there are two small pauses, each less than 1 millisecond each. Now, the reason the garbage collector was implemented this way was the first version, mark and sweep. It was due to simplicity, ease of implementation, and focus on correctness rather than latency. So what they did was implement an easy, correct algorithm and see how the people are using Golang. Once they understand that, people started complaining, then they went ahead and fixed it. So the thing to learn from here is do not overcomplicate stuff unless you absolutely have to. So the garbage collector is significantly better. Let's take a look at the next problem. Well, my trading app is making losses. Now, upon further investigation, it was concluded that the person has a trading app which relies heavily on timers. So they need to execute their trades at a specific time. If someone wants to schedule, let's say, a sale of 1,000 stocks at 12, now this needs to be done with high precision, and the failure to do so leads to losses of millions of dollars. And the complaint is that the Golang timers are not as accurate as they should be. Why, you ask them? So let's understand how the timers are implemented in Golang. To understand this, there is a min heap. So what is a min heap, you ask? Well, it is a data structure which allows you to fetch minimum element from bunch of numbers. So, well, it's the root element. So you can quickly fetch the root element, and it's the minimum number. So it stores two things. One is when, second is what. When is the deadline of this timer, when this timer needs to run, and what is the actual callback. So why this design was chosen? It's very simple, right? You maintain one data structure which contains all the timers. There is one go routine which picks up the root element and checks if it needs to be executed, it executes it, right? Easy to implement, simple design, protected by a lock. What could go wrong, right? Let's take a look and understand the problems with it. Well, first of all, every insertion in timer leads to heap rebalancing. And as a result, you have to basically rebalance a heap, and the time complexity for this is log of n. Now, it's not that bad, but imagine a case where there are a million HTTP requests, and each request has a context timeout. Now, that timeout will add one entry into this heap. That's, again, not a big problem, but compare it with global contention. To understand global contention in easier words, now we have coffee break after this, right? Imagine there were 300 people in this conference and only one stall for tea. What would end up happening? A lot of people waiting for their tea. Well, leading to angry gophers. How do you solve this problem? Well, wouldn't it be better if there were multiple tea stalls so people were divided evenly? Well, that is exactly what the Go team did. They made per P heaps, so the load gets divided evenly, making the timers more accurate. And you know what the best part of this is? Let's say you have an application, a stock application, which really needs the timers to be as accurate as they can. What you can easily do is increase the number of processors, making your timers more accurate, right? As soon as this statement was made, another person comes up. There are no gains after adding more CPU. Well, he's correct. If you see, the initial Golang programs were more network bound than CPU bound. So as a result, the initial setting of how many processors your program should use was set to 1. Now, why was it set to 1? as I said, the initial Golang program was more network bound rather than CPU bound. So how do you fix it? Well, since they realized that people are using Golang for more application bound use cases, they changed the default from 1 to number of CPUs, so your application can actually use full power of your CPU, making your application much better, much faster. By default, you don't have to do anything. But the key thing to note here is they already thought of this. So if you wanted to implement a CPU-bound application, the setting was configurable from the start, so you could always do that. It was not a limitation, just a default configuration. Now, as soon as this statement was made, another person jumps up. Well, this is not good enough. Now, I want you guys to take a look at this image and try and guess why this is not good enough. So, any volunteers? Anyone want to speak up? Right. So from the image, you can see that the CPUs are open, the doors are open, but there is a queue in only one of the doors. Well, the problem is load balancing. So in some cases, the CPU wasn't getting fully utilized because the scheduler wasn't allocating Go routines to every processor equally. As a result, like imagine an engineering team, right? Where 2 people are doing all the work and rest of the people are chilling in the cafeteria. Well, what should ideally happen? Well, everyone who is chilling in the cafeteria should realize and they should come and talk to their busier teammates and ask for work. So the work gets evenly divided and everyone is happy. Well, that's exactly what the solution to this is. It's work stealing scheduler. So every processor has their own queue, and if the queue is empty and they have no work to do, they ask other processors, hey, are you busy? Are you working? Give me some of your work. So the work gets evenly divided, and your application is more efficient, faster, better. Now, we have solved most of our problems, and there is one last question. Our app feels unreliable sometimes. Well, what could it be, right? We have solved most of our problems. Our processors are fully utilized. The load balancing is correct. Well, there is only one key element left. Well, if you listen and if you paid attention, everything which runs in Golang is a Go routine. Well, not everything, but Go routines are a very important part of Go applications, right? Your timers, Go routines. Garbage collector, Go routines. HTTP handler, Go routines. Now, these Go routines need to run concurrently on your processors, right? So to run your Go routines concurrently in your processor, we need scheduling. So if one Go routine is running, we need to tell him, hey, wait, there are other Go routines that need to run. So you need to pause, give chance to another one, and every Go routine gets time equally, right? So in initial versions of Go, we had something called cooperative scheduling. So every Go routine had some safe point where it can be paused. This could be a function call, an IO operation, a channel operation, etc. So once these safe points are reached, you could safely say, OK, now you need to stop, and another Go routine can get a chance to run. Well, what happens if you get stuck? If a Go routine gets stuck in a for loop where none of these safe points occur? Well, basically, one Go routine ends up taking up all the space and all the CPU time, and other Go routines get bored and or get starved. So this is called Go routine starvation. And how do you fix it? Well, to solve this problem, Go routine preemptive scheduling was introduced. Now, what happens is the Go scheduler checks if any Go routine is running for more than 10 milliseconds. If the answer to this is yes, a signal is sent, an OS signal is sent to this Go routine, And it says, OK, now you need to stop and give chance to other Go routines to run. So it can safely preempt and give chance to other Go routines to run. Now, as a result, as we have seen, the Go routines are equally divided on the processor. Since they are equally divided on the processor, your application runs faster. Not only your Go routine is equally divided in one thread, they are equally divided in every processor. So your application runs more efficiently, your timers are faster, your handlers are more efficient, your, your overall application is better and runs faster. As a result, everyone is now happy. Well, everyone except this guy, right? He does not look happy. Well, he is an introvert who couldn't speak up in a conference. Now, his problem, his problem is, but I'll still explain what his problem is. He has a microservice architecture where they communicate heavily using HTTP. And he was using default HTTP transport. But under heavy load, he was getting errors related to address translating and basically HTTP address not found. And if you want to know more about this, since he's an introvert who couldn't speak up at the conference, I'm not going to answer it or explain it further. If you are interested and want to know about it, talk to me after the talk. I'll be happy to explain it to you. Or if you are an introvert like him and not willing to speak at a conference, well, here's my LinkedIn. Send me a message, and I will be happy to talk to you. My name is Ali Hasan, and thank you so much for your time and attention. And if you have any questions, any suggestions, I'll be happy to answer them.